Welcome to the School of Life. Life is hard, but you have got to be harder. I'm Mrs. Collins, your life coach. Let's get started with Unit 2, Lesson 6, Quadrilateral Proofs. In this lesson, we have two essential questions. What are the properties of a quadrilateral? And how can I classify a quadrilateral on the coordinate plane? For this lesson, you will need to recall the distance formula. And the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So if need be, please go back to your lesson number 1 within this unit so that you can recall how to use the distance formula if you've forgotten. Okay, but as a review, we have two lines are parallel if they have the same slope. Two lines form a right angle if they have opposite reciprocal slopes. And then two sides are equal length if distance formula is the same. So if we calculate the distance formula for two sides of our quadrilaterals, we'll be able to determine that the two sides are the same if the distance formula is the same. So if we get the same answer after using our distance formula. Okay, so that was our review. How to classify quadrilaterals on the coordinate plane. First, we're going to graph the quadrilateral. Second, we'll find the distance for all four sides. This will tell you which sides are equal. Third, we're going to find the slope of all four sides. This will tell us which sides are parallel or if there are any right angles. And remember, we can determine right angles. Let me rewrite that part. Any right angles. And remember, right angles means perpendicular. Perpendicular means that we have right angles. So we're going to use the following information to name the quadrilaterals. This is kind of a flow chart that'll help us to determine our final answer as far as what quadrilateral do we see here. We're always going to start off with calculating the distance. We'll use the distance formula. Then we're going to notice a couple things. One, sometimes we'll notice that all four of those sides are exactly the same. Sometimes we'll notice that two pairs are the same. And sometimes we'll notice that nothing is the same. So depending on which answer we get, so for instance, if all four sides are the same, we're going to travel this route, and then we'll calculate the slope. After calculating the slope, you'll look to see, well, do I have any opposite reciprocal slopes? If you do, then you have something that's perpendicular and it's a square. If we do not, then it's not perpendicular and we have a rhombus. Same thing as a second example. If after calculating the distance, we have that two pairs of sides are the same, then you're asked, well, are these two sides next to each other? If yes, then it's a kite. If the two sides that are the same are not next to each other, but instead they're across from each other, then now we have to go and calculate the slope because this is either a rectangle or a parallelogram. If the slopes are perpendicular, then that means it's a rectangle. If they are not perpendicular, then that means it's a parallelogram. Our last option, if we calculate the distance and then we see that, well, none of the sides are the same, then we go ahead and calculate the slope. If we have one set that's parallel, one set of sides that's parallel, it's a trapezoid. But if we do not have any parallel sides, then it's just a quadrilateral, nothing special, just a regular quadrilateral, a four-sided shape. So this particular diagram is one that you may want to print out or copy so that you can use it for all of these problems. It will come in handy. So we have our examples. We're going to determine the best description of quadrilateral ABCD and prove using the slope and distance formula that this is either a square, a rhombus, a kite, a rectangle, a parallelogram, a trapezoid, or just a regular quadrilateral. In this particular problem, we're given 4 bordered pairs, one for point A, point B, point C, and point D. Before we can just draw that rough sketch of how quadrilateral ABCD looks, we need to actually sketch it on our coordinate plane. So I'm going to plot the points. So I've plotted the points A, B, C, and D. A, B, C, and D. You will always want to plot the points for these types of problems. If they give you the order pairs, plot them. And in addition to just plotting the points, label them. So this was point A, point B, point C, and point D. So again, big important things that you must do for these problems so that we don't get confused. After this, I'm going to go ahead and connect each point so that I have a quadrilateral. All right, so all 4 sides are connected. The next thing that I want to do is name these sides. So I have side A, B. I have side B, C. I have side C, D. And I have side D, A. Now, if you need to just have that visual, I'll point it out. Here's side AB from A to B. This is side AB. Here's side B to C, C to D, and here's side C to D to A. Okay, so what we need to do first is determine the distance between each of these points. So like, what's the distance between A to B? And that distance will represent this length. And if you go back to our flow chart from the first page, we were told to first calculate the distance. So we need to calculate our distances. Now, I will tell you that this very first step is a little bit of work. However, as you get the hang of it, you should be able to do this in a jiffy. We're going to go over a few examples where we are showing all of the work, but then for the rest of the notes, you'll be pausing the video and calculating those distances on your own, just to make sure that you still are able to use the distance formula. I'm going to put in one more thing that I find helpful. I'm going to actually put the order pairs here over each of my, or by each of my points, simply so that I have it as a reference, so that as I'm calculating the distance, I'm not totally confused. Okay, so up here, I'll write my side work. And this is the side work for number 1. So we need to know the distance between A and B. So distance from A to B. Our 2 points for A and B. A is at the point -2, 6, and B is at the point 2, 7. Label your points. This is X1 and Y1. This is X2 and Y2. We have that the distance is the square root of our X2, which is 2, minus X1, which is our -2, squared, plus Y2, which is 7, minus Y1, which is our 6, squared. This will be equal to the square root of 2 minus a -2 is the same as 2 plus 2. So we have a 4 squared plus 7 minus 6 is 1 squared. So 4 squared, this is 16, plus 1 squared is 1. This is equal to the square root of 17, and we will not break that down any further. So AB is the square root of 17. We have this first side. The first side is the square root of 17, AB. Okay, then we continue with our next calculation. So we need the distance from B to C equals. And again, I like to write those points down. So B was 2, 7. This is the point B. And the point C is 1, comma 3. So we have our x1, y1, x2, y2, and let's go ahead and begin. So we have x2, which is 1, minus x1, which is 2, squared, plus y2, which is 3, minus y1, which is 7, and then squared. This equals the square root of 1 minus 2 will give us a negative 1 squared, plus 3 minus 7 is a negative 4 squared. A negative 1 squared is negative 1 times a negative 1, so that's 1, plus negative 4 squared is negative 4 times negative 4, which is 16. So we get 1 plus 16, which is the square root of 17. Our side BC is also the square root of 17. So here we have the square root of 17 also. Okay, let's continue. We have the distance from C to D. So I like again to write down my 2 points. Here's C. C is at 1, 3. And D is the point negative 3, comma 2. So you have x1, y1, x2, y2. And let's go ahead and plug them into our distance formula. x2 is negative 3 minus our x1, which is 1, squared, plus y2 is 2 minus 3 squared. So it's equal to negative 3 minus 1 gives us a negative 4 squared, plus 2 minus 3 is negative 1 squared. So we have the square root of negative 4 squared is 16, plus negative 1 squared is 1. So 16 plus 1 gives us 17. So this is the square root of 17. So we have CD is also the square root of 17. So we have a third side whose length is the square root of 17. All right, one last side to calculate, and that's side DA. We don't know what the measurement of side DA is. But if you're kind of thinking about it, I'm almost certain that DA is going to be the square root of 17 as well. But we have to go ahead and calculate it. So the distance of D to A. Well, point D is negative 3, comma 2. And point A is negative 2, 6. Okay. So once again, I like labeling x1, y1, x2, and y2. And let's plug it all in. The square root. x2 is negative 2 minus our negative 3 squared, plus y2 is 6 minus y1 is 2 squared. So equals a negative 2 minus a negative 3 becomes negative 2 plus 3. And that answer will give us 1 squared. And then 6 minus 2 is 4. So we have plus 4 squared. 1 squared is 1, plus 4 squared is 16. And once again, we have the square root of 17. So the distance between D and A is also the square root of 17. So this side is the square root of 17. Okay. At this point, if you go back over here to our little diagram, they told us to calculate the distance. We just did. We found out that all 4 sides are the same. Since all 4 sides are the same, our next step is to calculate the slope. And what we're going to do is see whether or not we have perpendicular sides or not perpendicular sides. If they're perpendicular, it's a square. If not, then it's a rhombus. So our step number 2 now is to go ahead and calculate the slope. To calculate the slope, we'll need the slope formula. So m equals y2 minus y1 over x2 minus x1. Alright, so in calculating the slope, we'll need the slope of side AB. We'll need it of BC, CD, as well as DA. So we're going to need to do some more side work to calculate our slopes. As before, when we were working on the distance formula, I love to write down the points that we're working with, simply so that we have the correct numbers in front of us. So the slope of AB. Well, for point A, that's the point -2, 6. And point B, we have the point 2, 7. Labeling x1, y1, and x2, y2. Plugging it into our formula. Y2 is 7 minus y1 is 6 over x2 is 2 minus our -2. 2 minus a -2 will give us a 2 plus 2. Working across, we have 7 minus 6 is 1 over 4. So our slope for the first one is 1/4. Moving right along, we have the slope of BC. Well, point B is the point 2, 7, and C is 1, 3. Labeling our points, you have x1, y1, and x2, y2. So our slope, plugging everything in, we'll have 3 minus 7 over 1 minus 2. 3 minus 7 gives us a -4. And 1 minus 2 will give us a -1. Well, a -4 divided by a -1 is actually the same thing as a +4 over a +1, which is simply 4. Negative divided by negative gives us 4. So this would be a 4. Slope of BC is a 4. Continuing, we have the slope of C to D. Point C, just for our reference, is 1, 3. And point D is -3, 2. Labeling, you have x1, y1, and x2, y2. Plugging it all in. Y2 is 2 minus 3 over -3 minus 1. 2 minus 3 gives us -1 over -3 minus 1 gives us a -4. So we have -1 divided by -4. That gives us a 1/4. Negative divided by negative is a positive. So just positive 1/4 is our answer here. Okay, so then we have our very last one to calculate. And our last one to calculate will be the slope of DA. So the slope of DA. So the slope of DA. So first off, noting that D is the point -3, 2. And A is the point -2, 6. So we label our points, x1, y1, x2, y2. And we'll have 6 minus 2 over -2 minus a -3. 6 minus 2 gives us 4. And then -2 minus a -3 is the same as -2 plus 3, which is 1. So that's 4 over 1, which equals just 4. So here, our slope of DA is a 4. So we have our 4 slopes. AB is 1/4, BC is 4, CD is 1/4, and DA is 4. So first off, you should be able to identify that AB and CD are parallel to each other because they have the exact same slopes. BC and DA are also parallel to each other because they have the same slopes. But what we're looking to do is figure out, well, are these opposite reciprocals? So AB and BC, these two numbers, are they opposite reciprocals? So you have 1/4 and then you have 4. 1/4 and a 4. So 1 over 4 and then you have a 4, which is like 4 over 1. Are these opposite reciprocals? The answer is no, they are not opposite reciprocals. And they're not opposite reciprocals because they're both positive. Positive 1/4 and a positive 4 over 1. They are reciprocals, which means flipped, but one is not negative while the other fraction is positive. So in this case, they are not perpendicular. And so then let's go back over to our flow chart. After calculating the slope, we're finding out that they're not perpendicular. So this is a rhombus. So our answer here is that this quadrilateral is a rhombus. Because the sides are equal but not perpendicular. Okay, the sides are equal, but they're not perpendicular. So this is a rhombus, not a square. For number 2, I am going to go ahead and do some preloading. I'm going to write down all of the information that we're going to need to fill out, and then we'll move on from there. So very first thing is we'll need to sketch our points. So sketch our quadrilateral by plotting our points. Alright, so we have sketched our quadrilateral EFGH. So EFGH is our quadrilateral here. What you'll want to do is write down the side name, which are EF, FG, GH, and HE. Very first thing is to go ahead and find the distance. And after we found the distance, we'll be finding the slope. So remember the distance, we're going to use the formula D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And for our slope, we'll be using the formula M equals y2 minus y1 over x2 minus x1. And we'll find it for EF, FG, GH, and HE. Alright, so we'll begin with finding the distance for each of our side lengths. So EF, FG, GH, and HE. And here's that work over here. So we have EF. EF, we have our 2 points, -3, 3, and 1, 5. Plugging in all of our numbers, we will have 1 minus our -3 squared plus 5 minus 3 squared, which is equal to the square root. 1 minus -3 gives us 4 squared plus 2 squared, which is equal to the square root of 16 plus 4, which is equal to the square root of 20. The square root of 20, we can break it down, so we will. Let's prime factor it, do our factor tree. So we have 4 times 5. Break it down our 4, we have 2 times 2. So 2 times 2, this is our pair of 2's. So our answer, we can take out one of those 2's. Our 5, we cannot break down any further. So it's 2 times the square root of 5. And that's our distance for EF. So E to F has a distance of 2 times the square root of 5. Going to our next one, the distance for FG. Plugging in our values, we have 4 minus 1 squared plus -1 minus 5 squared, which gives us 3 squared plus a -6 squared. So that's equal to 9 plus 36. And 9 plus 36 gives us the square root of 45. Once again, the square root of 45, we can break this one down. So we have that 9 times 5 gives us 45. 9 we can break down to 3 times 3. Here's our pair of 3's. So we're going to take out a 3. And then left is the square root of 5. So 3 times the square root of 5 is the distance for FG. For GH, we have 1 minus 4 squared plus -5 minus -1 squared. And that's equal to the square root of -3 squared plus a negative 5 minus a negative 1 gives us a negative 4 squared. So this is equal to a negative 3 squared is 9 plus negative 4 squared is 16. So 9 plus 16 gives us the square root of 25. The square root of 25 is equal to 5. So this distance is simply 5. And lastly, we have negative 3 minus 1 squared plus 3 minus a negative 5 squared, which is equal to the square root of negative 3 minus 1 is negative 4 squared, plus 3 minus a negative 5 gives us 8 squared, and we have the square root. Negative 4 squared is 16 plus 64, which is equal to the square root of 80. And the square root of 80, we can break it down into a 10 times 8. 10, we could break it down to 2 times 5. For 8, we could break it down into 2 times 4. For 4, we could break it into 2 times 2. So here we have a pair of 2's, and we also have a pair of 2's here. So we're going to take out 2 2's. And then lastly, we'll have that 5 left inside. And if we multiply that together, 2 times 2 will give us 4 times the square root of 5. So this answer is 4 times the square root of 5. So filling in all of our side lengths, EF, we had 2 times the square root of 5. FG, we have 3 times the square root of 5. GH, we have 5. And HE, we have 4 times the square root of 5. Alright, if we continue and look at our slopes, we have our side work for figuring out the slopes. We have ED. To find the slope, we'll take our y2 minus y1 over x2 minus x1 for each of our little problems here. So for E, this should be EF, not ED, I'm sorry, EF. So we should have 5 minus 3 over 1 minus negative 3. 5 minus 3 gives us 2 over 1 minus a negative 3 is 4. 2/4 reduces to 1/2. So this slope is 1/2. For FG, we'll have negative 1 minus 5 over 4 minus 1. Negative 1 minus 5 gives us a negative 6. Over 4 minus 1 is 3. Negative 6 divided by 3 gives us a negative 2. That's our slope for FG. For GH, we have a negative 5 minus a negative 1 over 1 minus 4. Negative 5 minus a negative 1 will give us a negative 4 over 1 minus 4 gives us a negative 3. To simplify this, a negative divided by a negative gives us simply a positive 4/3. Is our slope there. And then lastly, the slope for HE, we have 3 minus a negative 5 over negative 3 minus 1. 3 minus negative 5 gives us an 8 over negative 3 minus 1 is a negative 4. And if we simplify it, 8 divided by a negative 4 gives us a negative 2. So filling in our slopes, EF has a slope of 1/2. FG has a slope of negative 2. GH has a slope of 4 over 3. And HE has a slope of negative 2. So let's go ahead and analyze what we're given here. We have our side lengths. If you notice the side lengths, all of them are different. Okay, we don't have any pairs that are exactly the same. Not even the opposites, not the opposites, not the ones that are next to each other. All of the side lengths are different. So thinking back to our diagram here, we've calculated each of our distances. In this case, all four were not the same. Two pairs were not the same. We had that anything else thing going on here. So we're going this direction. Okay, so then we calculated our slope. And so let's see if we had anything that was parallel. So in our slope, we're looking for something with the same slope. FG and HE had the exact same slope. So since those two have the exact same slope, we have one set of parallel lines or parallel sides. So therefore we have a trapezoid. So this is a trapezoid. Okay, so this quadrilateral is a trapezoid because it has one set of sides that are parallel. That's a trapezoid. All right, so at this point, I'm pausing to give you a little bit of commentary. For these problems, we have to figure out the distance for all four sides, as well as the slope for all four sides of our quadrilaterals. It is pretty time consuming. However, it can be done. You have the skills for finding the distances, as well as you have the skills for finding the slopes. The only added thing or component is just looking at your side lengths, narrowing down which quadrilateral you could possibly be looking at, and then looking at your slopes to further figure out which quadrilateral you have information for. For the following problems within the notes, I am going to ask you to pause the video, and what you're going to do is make your calculations on the side for the slope as well as your distance formula, and then determine which quadrilateral is being represented by the data that you've been given. But for every single problem for the rest of your notes, pause your video and test yourself. See whether or not you can identify the quadrilateral that is being described. All right, so you should have drawn out your diagram for number 3 and then label your four sides. When you're looking at your diagram, you have a side LO, OV, VE, and EL. All right, so for number 3, so far you should have figured out that the square root of 50, which is 5 times the square root of 2, is the side length for LO. OV is the square root of 10, VE is the square root of 10, and EL is the square root of 50, which is also 5 times the square root of 2. If you draw that into your pictures, you should see that LO is congruent or equal to LE. And then you should also see that OV is the same as VE. And lastly, after you've calculated the slopes, you should have gotten that LO has a slope of 1, OV has a slope of negative 1/3, VE has a slope of 3, and EL has a slope of 1/7. If you go back to those side lengths, and noticing that you have two congruent or two equal sides that are right next to each other, the only quadrilateral that this would fit is a kite. This is a kite because we have two sets of equal sides and they are next to each other. And the keywords are next to each other. That's what helps us to know that this is a kite. All right, for numbers 4 and 5, please try the 2U try problems. All right, so our answer for number 4 is that this quadrilateral is a square because all sides are equal and the slopes are perpendicular. Please take a look at the work. All right, and lastly, number 5, this quadrilateral is also a square because all four sides are equal and the slopes are perpendicular. And that concludes our lesson for today. Please make sure that if you need to rewind and go back and look at any problems that you do so. If you have any questions, please feel free to ask.